An introduction to polyatomic ions. Not all ions are monatomic. For example, chloride is monatomic, one atom, that atom being chlorine. But what do you do for this giant ionic compound here? And you might recognize that rock as being limestone. What is limestone? Well, really it's just a relatively hard, and for climbers sometimes not hard enough, form of chalk, and chalk is calcium carbonate. Fine, let's figure out what those ions are. Calcium, Ca, yeah, it's going to form a 2 plus charge. But carbonate, it's not on the periodic table. And in fact, carbonate is a 4-atom based ion. It is the CO3 2 minus ion. For now, we're not going to go into exactly how those carbon and oxygen atoms align themselves, why they're minus 2. Let's just recognize that there are polyatomic ions, and that means more than one atom ions, like this one has 4. And here's an example, the carbonate dianion, like this. Do not make the mistake of thinking that we have 3 carbonate anions. We do not. We have one CO3 2 minus anion. The formula should be one of each is fine. Those little charges there are really your personal notes at that point, and a +2 offsets a -2. Remember, ionic compounds are uncharged. And what is the polyatomic ion? Well, as we said, it's the carbonate dianion. Other examples include sodium cyanide, where sodium is monatomic, and in fact the only common diatomic cation is the ammonium cation, NH4+. So Na plus for sodium, Cn minus, excuse me, Cn minus for the cyanide. Charges are +1 and -1, so we don't need to use parentheses or anything fancy to represent this. But if we've got calcium hydroxide, you can refer to a table. In our class, it's at the bottom of the periodic table, or in some classes you may have to memorize these. A hydroxide is a -1 anion. Now you could write your personal notes, put a +2 up there, put a -1 there, and drop and switch, and you'll get it right. But do not just write CaOH2 without the parentheses. After all, we need 2 hydroxides, not 1 oxygen and 2 hydrogens. This is polyatomic ions.